sama-sama nating balikan. Lasang natin aabot kahit nasan ka man. Sa gitna ng panubok na panahon, kahatid sila kaakibat ay diskusyon. Sama-sama tayo kahit magkalayo. Sa programang ito, tag ang pagkatuto. Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo. Makinig, manood na sa Teleradyo. Makinig, manood na sa Teleradyo. Nananabik
Good morning, Delpilarians! Welcome back to another episode of Learning Science here at Teleradio Marcelo, ang telearalan ng bawat malulenyo. I am Ma'am Kim Diaz, your teacher broadcaster for today. And together, let's discover and be amazed by the amazing secrets of science. Please prepare your pen and self-learning modules and let us examine, explore, and experience the deeper layers of the Earth's lithosphere. Before we start our discussion proper, let's have our opening prayer. And we're back. Before we start our session for today, let's refresh our minds of what we have learned from the last week's topic. We have 5 questions for you to answer. I will read each question and choices, and all you need to do is to choose the letter of the correct answer. And then you only have 5 seconds to answer each number, okay? All right, ready? Here we go. Number 1. Which of the following is the type of rock formed when lava or magma cools and becomes solid? Is it letter A, sedimentary rock? Letter B, metamorphic rock? Letter C, igneous rock? Or letter D, the resulting material is a mineral, not a rock? Again, which of the following is the type of rock formed when lava or magma cools and becomes solid? Is it letter A, sedimentary rock? Letter B, metamorphic rock? Letter C, igneous rock. Or letter D, the resulting material is a mineral, not a rock. You have 5 seconds to answer, and then your timer starts now. Okay, let me see. Let's see your answers. Hello, ABM. 11, ABM, A, B, C, D, E. Hello, guys. All right, so let's see the answer. So the correct answer is letter C. Good job, guys. Okay, so let's have the second question. In which of the following rocks can fossils be found? Is it letter A, sedimentary rock? Letter B, metamorphic rock? Letter C, igneous rocks? Or letter D, fossils are found in soil, not on rocks? Again, in which of the following rocks can fossils be found? Is it letter A, sedimentary rock? B, metamorphic rock? C, igneous rocks? Or letter D, fossils are found in soil, not on rocks? Go. What is your answer? Is it letter A, B, C, or D? Okay, let's see. I'll be waiting your answers. All right, so the correct answer is, of course, it's letter A. It's sedimentary rock. Okay, let's move on to number 3. When describing the sizes of minerals, grains on rocks, which of the following is being described in detail? Is it letter A, texture, B, composition, letter C, sedimentation, or letter D, hardness? Let me repeat. When describing the sizes of minerals grains on rocks, which of the following is being described in detail? Is it letter A, texture, B, composition, C, sedimentation, or D, hardness? Let's see your answers. Okay, so yeah, the correct answer is letter A, it's texture. All right, number 4. Which of the following is the process of breaking down rocks into sediments? Is it A, deposition, B, erosion, C, weathering, or letter D, letters B and C? Again, which of the following is the process of breaking down rocks into sediments? A, deposition, B, erosion, C, weathering, letter D, letters B and C. What is the correct answer? Hello, guys. Write your answers or comment your answers in the chat box, and I will be waiting. Okay, let's see. All right, very good. So the answer is, of course, it's letter C, weathering. Now, last number 5. Which of the following is the process in which dissolved minerals crystallize and glue sediments together? Letter A, compaction, B, deposition, C, sedimentation, or letter D, cementation? A, B, C, or D? Again, let me repeat. Which of the following is the process in which dissolved minerals crystallize and glue sediments together? A, compaction, B, deposition, C, sedimentation, or letter D, cementation? Okay, answers are coming in. Right, so most of your answers is correct. So it's letter D, cementation. Good job. Did you get the answers correctly? Of course. Yeah, good job. Great in that. To those who got 4 to 5 points, you did an impeccable job. And to those who might have forgotten some of the key areas of last week's episode, you can always rewatch the episodes of Earth and Life Science. Do your best, everyone. Okay, so as an intro to our topic for today, let me spill this episode's objectives. Number one, describe where the Earth's internal heat comes from. And number two, describe how magma is formed or magmatism. As you have learned from our first episode, the Earth is the only known planet in the universe to host life forms. And the three unique attributes of our planet that made this possible are number one, the presence of liquid water. Number two, plate tectonics. And number three, atmosphere. However, in addition to these three unique attributes, another factor that contributes to making the planet livable is heat. Setting aside the downsides to heat, such as affecting the efficiency of machines, as well as the discomfort and health problems attributed to extremely hot weather, heat is undisputedly an important factor in sustaining life. From something as simple as cooking eggs and boiling water to allow organisms to function at their best and causing convection currents in the mantle, heat does quite a lot. But where does the Earth's heat come from? Do you know? The simplest answer is the sun. Considering how much energy it brings to the Earth, however, thinking about volcanoes and the magma that flows inside them, you would come to know that there must be another heat source underneath. But what are those? The heat from interior of the Earth comes from two sources, the primordial heat and the radiogenic heat. Okay, let's see. Primordial heat is the heat left over from the formation of the Earth. It is the heat energy that accumulated in the planet in its first few million years of evolution. Fascinating, isn't it? Yeah, it is. Radiogenic heat, on the other hand, is heat produced by radioactive decay of unstable isotopes in the mantle and the Earth's crust. Simple? Yeah, let's keep going. Heat can be transferred in three different ways. We have convection, conduction, and radiation. I am sure that you are all familiar with these, but the first you've encountered this, they were each simply defined as: for conduction, the transfer of heat through direct contact. There. For the convection, the transfer of heat through a fluid medium, such as water or air, and etc. And radiation, the transfer of heat that requires no contact or medium between the source and the receiver, such as with how heat is transferred from the sun to the earth. Today, we'll define these three more accurately. Let's have the conduction first. Conduction is the transfer of heat through the collisions between atoms and molecules. In solids, the molecules are tightly packed together, transfer energy through collisions due to the vibration of molecules. In fluids like liquids and gases, conduction occurs during collisions of molecules as they collide, as molecules randomly move and bounce around or transfer along concentration gradients. Next is radiation. Radiation is the energy emitted by matter in the form of photons or electromagnetic waves. Sounds familiar? Yeah, that's exactly the dual properties of light. Photons and electromagnetic waves are able to travel through a vacuum, allowing the transfer of heat without the involvement of molecular collisions or molecules themselves. That's how the sun had been providing the earth with abundant energy. Wow, amazing. And lastly, we have convection. There you go. Convection is the transfer of heat from one place to another due to the movement of fluid, or more specifically, the movement of molecules in fluid substances. The said movement is mostly the downward and upward movement caused by the changes in density, caused by being heated up and cooled down. Remember that heat makes fluids, both liquids and gases, less dense, and colder fluids sink. This is what happens when you boil water through a stove. The water molecules from the bottom of the pot are the ones to be heated, since the fire is underneath the kettle. The heated water molecules become less dense and move to the top of the kettle or pot. And the heated molecules, which are now colder than the heated molecules, will sink. Recall what we mentioned a while ago about heat causing convection current in the mantle? That is an example of convection. The heat from the Earth's core heats up the magma at the bottom of the mantle and causes them to move up. Then, the magma from the upper levels of the mantle sinks due to the difference in density. Remember how warm air rises and cold air sinks? It is the same with the previous examples, except with water and molten rocks. Yeah, that's what I call amazing. And now, speaking of molten rocks, do you know how magma is formed? Anyone? Can you tell me how magma is formed? Let's see the chat box or the comment box, and I will wait for your answers. All right, so while waiting, magma is formed at the lower crust and the upper mantle through what is known as partial melting. Okay, partial melting is, as the name implies, melting of only a portion of a solid, rocks in particular. This is due to the differences in the melting points of a rock's components. Okay, I'm waiting for your answer. Let me hear your thoughts about the magma. What is the meaning of magma? What is a magma? Okay, there are three possible causes for melting to occur in the mantle. Number one, or the first one, is the increase in temperature. Remember how convection moves magma heated at the lower portion of the mantle towards the upper portion of the mantle? The rising magma contains a much higher temperature, which was enough to begin the melting of rocks. Okay, so the second possible cause is again attributed to convection currents. As the magma moves up, they carry with them rocks that did not melt due to the increased pressure at the lower areas of the mantle. When these rocks are brought up to shallower levels, they begin to melt due to the decrease in pressure. And the last one is through the addition of volatiles. Volatiles like water and carbon dioxide can lower the melting point of certain substances. If a rock is already close to its melting point, the addition of volatiles can be enough to trigger partial melting. Okay, did you understand the three reasons or the possible causes for melting to occur in the mantle? Okay, so if so, that's wrap everyone. And now, do you have any questions about this, about the topic? If there are questions, feel free to ask me through our comment box and I will address and answer your questions. Okay? And if there are no more questions, we will end our episode for today. But let us have a test how much you've learned. I have here 5 questions. Again, I will read it one by one, and along with the question is the choices. Okay, are you ready? Ready? Yeah, of course you are. Let's go. Let's read number 1. Which of the following is not considered the Earth's source of heat? Again, number 1. Which of the following is not considered the Earth's source of heat? Letter A, primordial heat. Letter B, radiogenic heat. Letter C, sun. Or letter D, none of the above. Which of the following is not considered the Earth's source of heat? What do you think? Okay, so answers are coming in. Of course, the answer is letter D, none of the above, because all of these are sources of Earth's heat. Very good. Now, let's have number 2. Which of the following modes of heat transfer does not require a medium? Letter A, conduction. Letter B, convection. Letter C, radiation. Or letter D, subduction. Is it letter A, B, C, or D? Let me repeat. Which of the following modes of heat transfer does not require a medium? Conduction, convection, radiation, or subduction? Okay, so I'm seeing correct answers. Yeah, it's letter C. Very good. Good job. It's radiation. Wow, you're doing a good job, everyone. Okay, let's move on to number 3. Okay. Which of the following will change when a molecule is heated? Letter A, composition. Letter B, density. Letter C, texture. Or letter D, mass. Again, which of the following will change when a molecule is heated? Letter A, composition. B, density. C, texture. Or letter D, mass. What do you think is the answer? 5 seconds. 5, 4, 3, 2, and 1. Okay, let us see. The correct answer is letter B. Wow. So who got it right? I'm seeing correct answers. Awesome. Okay, let's move on to number 4. Which of the following must decrease in order to trigger partial melting in the mantle? Letter A, temperature. Letter B, pressure. Letter C, volatiles. Or letter D, size. Again, which of the following must decrease in order to trigger partial melting in the mantle? Letter A, temperature. B, pressure. C, volatiles. Letter D, size. What is the correct answer? Okay, hello, ABM, UMS, Arts and Design, TVL. Hello there, and to all our grade 11 who are currently tuned in with us today. Okay, so the correct answer is, of course, it's letter what? B, it's pressure. Good job. Last one, last question. Okay, number 5. Which of the following must be added in order to trigger partial melting in the mantle? Letter A, temperature. B, pressure. C, volatiles. Or letter D, size. Let me repeat. Which of the following must be added in order to trigger partial melting in the mantle? Letter A, temperature. Okay, very good. Letter B, pressure. Oh, that was fast. Letter C, volatiles. And letter D, size. Unclear. Very good. It's letter C. That was fast. Oh, nice try, Mikaya. Nice try. But the answer is letter C. Okay. Okay. Letter C. Yeah, it's letter C. Good, good. Amazing. So that concludes our discussion for today. Okay, so answers are still coming in. All right. So see you again next week as we examine, explore, and experience more amazing topics here at Teleradio Marcelo. Before I say goodbye, let me acknowledge our team behind this week's episode. So, Ma'am Kim Diaz, yours truly, your teacher broadcaster for today. Sir Hideo Kobayashi, our script writer, and Sir Russell Gerald Rayo, our technical director. That's all, everyone. I hope you enjoyed our adventure for today. Continue your explorations, dear students, and keep in mind what Marie Curie, the 1911 Nobel Prize winner and discoverer of polonium and radium, once said, "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less." Oh, what a nice quotation. All right, so once again, I am your teacher broadcaster, Ma'am Kim Diaz. Thank you and stay safe. See you guys.
Radyo is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa teleradyo. Please take time to send your feedbacks via Teleradyo Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow bit.ly ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradyo Mu, kung saan ang feedback mo, suggestions nyo ay mahalaga sa Teleradyo.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo.